Hi, everyone. We've talked about two-tailed tests here in the context of the magician's coin. Let's continue with the magician's coin and now talk about right-tailed tests and left-tailed tests. So in a typical right-tailed test, the alternative hypothesis, bear in mind that the tails correspond to the alternative hypothesis, okay? For example, in the two-tailed test, right? Imagine that this is a number line for P. Okay, then in the two-tailed test, the alternative hypothesis favored both the right tail, the higher values of P, and this left tail, the lower values of P, away from zero 0.5. So in a two-tailed test, the alternative favored both the right tail and the left tail on this P number line. Now, in a right-tailed test, the alternative hypothesis favors the right tail. And remember, the tail corresponds to the alternative hypothesis. Okay, we have a right-tailed test here. Here, the alternative states that the value of a population parameter is greater than a particular reference value. Again, think of the alternative as favoring the right tail of the real number line, corresponding to greater values of the parameter. So in our example, well, the magician's coin example, we want to test the claim that a magician's coin is biased towards heads. Biased towards heads at the 0.01 significance level. So we can let P be the probability that the coin comes up heads, as usual. And here is a possible setup for this right-tailed test. It's the one that we typically write up. So the idea of being biased towards heads, that means that the probability of getting a head will be greater than 1/2. So the claim is that the magician's coin is biased towards heads. And we should indicate which is the claim, the null or the alternative. Up here in the prior example, the null was the claim when we claimed that the magician's coin is fair. Here, the alternative hypothesis is the claim. Again, the claim could be the null hypothesis or the alternative hypothesis, depending on the wording of the problem. And alpha is 0.01. That's very straightforward. No tricks there. Now, again, the alternative says that P is greater than 1/2. And remember, the null hypothesis and the alternative hypothesis basically divide up the world. We live in a world where either the null hypothesis is true or the alternative hypothesis is true. Now, the alternative hypothesis says that P is greater than 1/2. The null hypothesis would then have to say that P is less than or equal to 1/2. Use a different color here, green. The null says that P is less than or equal to 1/2. Because again, we live in a world where either the null is true or the alternative is true. Now, the idea of being biased towards heads, that corresponds to a tail. On this P number line, the bias towards heads corresponds to the right tail, higher values of P. The null hypothesis always contains the case of equality. So over here, P is greater than 1/2, that's the claim. P is less than or equal to 1/2, that's the null. And the null hypothesis, whenever you have this reference value involved, the null always contains the case of equality. Now, as you saw me do here, in this example, it may be easier to set up the alternative hypothesis first, because the claim here, the bias towards heads, that implies a tail, that corresponds to the alternative hypothesis. And that's fine. You can write the alternative hypothesis first. Okay? And then use the fact that the null is everything that the alternative is not. Now, an easier way to look at this, it is conventional that instead of writing P as less than or equal to 1/2, we simply write P equals 1/2. It's a kind of shorthand almost. All right. But really, it means that P is less than or equal to 1/2. So this really means that. For convenience, we often write this, and it is conventional to write this null hypothesis as P equals 1/2. The alternative is the same as before. P is greater than 1/2, which is still the claim. Okay, same as before. So books almost always write P equals 1/2. And again, absorbed in this is the case of P being less than 1/2. One reason why this is convenient to do is that, well, for one thing, the equal sign is more familiar to us, but also remember, the null hypothesis is the assumption that calculations are based on. So in that sense, when we say that we're performing calculations under the null, if we just say, okay, let's assume P equals 1/2, then it's more straightforward to work calculations based on that assumption. Although it also includes the cases where P is less than 1/2. Basically, P equals 1/2 represents the boundary case. Okay, it's the case that's closest to the alternative without being the alternative. It's like the boundary case. Again, when we calculate, it's easier to assume that P is straight up equal to 1/2. I should write this in green. The green is the null here, right? It's easier to say that P equals 1/2, although technically, in fact, it really means that. Okay. Again, think of 1/2 as the borderline case of P being less than or equal to 1/2. So that was the deal with a right-tailed test. With a left-tailed test, well, no surprise there. In a typical left-tailed test, the alternative states that the value of the population parameter is less than a particular reference value. So in a left-tailed test, the alternative looks towards the left tail. Right now, we're looking at values for P, but this could be a number line for mu or sigma squared, for example. In example 3, we want to test the claim that a magician's coin is biased towards tails at the 0.10 significance level. Now still, even though we're talking about tails here, we could still let P be the probability the coin comes up heads. That's okay. And here's a possible setup for the left tail test. Again, it might be easier to set up the alternative first. The claim is that the bias is towards tails, which means that the probability that the coin comes up heads would be less than 1/2. A bias against heads and towards tails. So again, it's easier to write the alternative in this case. The alternative would not include the case of equality. This alternative favors a tail. Now over here, well, here, I guess you could say in the end, this also favors a tail, but it's not the tail that's specified in the claim here. All right. Now, the thing is, it's a left tail test because the alternative favors the left tail. The alternative favors a left tail, so that's why it's a left tail test. It's a left tail test because the alternative favors the left tail of this number line for P. The null favors the right tail in the case of equality. And again, it may be easier to set up the alternative first, that was the claim, and then use the fact that the null is everything that the alternative is not. So here, P is greater than or equal to 1/2 would be the null. But once again, it's conventional to write, instead of is greater than or equal to, it's conventional to write a straight up equal sign. P equals 1/2. It's very conventional for books to write that, the borderline case. And this assumes that. So really the null includes the case of P being greater than 1/2, but we're focusing on the boundary case because that's what we base calculations on. Okay, so again, remember that the alternative tells us what kind of test we have. Here, we have a left tail test. It favors lesser values for P. And yes, it is typically the case that in a one-tail test, the claim would correspond to the alternative, because that's the case where it's easier to set up the alternative claim. But not always. In the usual case, yes. In a one-tail test, the claim often refers to the alternative, but not always. And again, right-tail test and left-tail test are two types of one-tail tests, which means that the alternative favors more one tail as opposed to the other. And for both one-tailed and two-tailed tests, the null includes the case of equality, which is a reason why, for the null hypothesis, you almost always see written or typed the parameter equals the reference value, in this case, 1/2. Now, in principle, a null hypothesis can consist of any one of these signs, an equal sign, or these inequality signs, but for all practical purposes, we tend to write that. Okay, next up, how do you decide whether to reject the null or not? Next time.